So in this video, we're going to talk about writing a quadratic equation given specific key features. And so we have some ideas here that we could possibly use standard form. We've talked about vertex form, and we have factored form. All right, and it's going to depend on what key features we're given. So let's read through problem number 1 here. It says write the equation of a quadratic function with a vertex point of 7, negative 5 that passes through the point of 9, negative 3. As soon as you see that you are given a vertex, we know we need to be working with vertex form. So what does vertex form look like? That's y equals a times x minus h squared plus k. Now, our vertex point in the problem is the point 7, negative 5. That vertex corresponds to the h and k in our format here. hk is the vertex. The other point, in this case 9, negative 3, it's just any point on the quadratic falls into x, y. So these 2 points, 7, negative 5 and 9, negative 3, give us 4 different pieces of information that we're going to fill into this equation. All right, so we're going to replace y with negative 3. The thing that we don't know is what our a value is. That's what we're going to figure out. So x is going to get replaced with 9 minus h gets replaced with 7 squared plus k, so plus negative 5. Okay, so every single thing in this equation has been replaced except our a value, so that's what we want to figure out. So what I'm going to do is I'm going to move this negative 5. So I'm going to add 5 to both sides. Okay, so that's gone. I'm going to get 2 here equals a. Now, inside the parentheses here, I've got 9 minus 7. Well, 9 minus 7 is 2 squared. All right, so 2 equals a times 4. 2 squared is 4. So I'm going to divide by 4 on both sides. Simplify my fraction, so a is equal to 1/2. Now, all of this work that we just did here was to figure out what the a value is in the vertex form. Okay, so we know our vertex is 7, negative 5. We know our a value is 1/2. So now we're going to actually write the equation using that information. So you can either write f of x or y. It won't matter. Okay, we know our a value is 1/2. We're going to leave x as x minus 7 squared. Now, for the final equation, instead of writing plus a negative 5, I'm just going to write minus 5. It means the same thing. Okay, and that's the equation of the quadratic function that passes through the vertex of 7, negative 5 and also goes through the point of 9, negative 3. Okay, so the reason we leave x as x here and f of x as f of x to represent any point on this graph, not just this specific point. Okay, so that's if we have a vertex and a point, and letting you know, just a little FYI, that's all we're going to be looking for is giving you a vertex and a point. Okay, so we're going to focus on vertex form for these problems. So problem number 2, we have a vertex point of 5, 7, and we have another point of 1, negative 9. Okay, so you can either write out 5, 7, which would be the HK. If you just want to make a little note here, like this is H, this is K, that's totally fine. Just make sure that you identify the vertex versus just the random point that your parabola goes through, your quadratic goes through, because that's the XY. All right, so vertex form has not changed since the first problem, but I'm going to rewrite it. It helps me when I write it multiple times to get it cemented into my brain of what the format looks like. So y equals a times x minus h squared plus k, and I'm going to replace x, y, h, and k with the information that I know from my vertex point and the other points that the graph goes through. So let's see, negative 9 equals the thing we don't know, which is a. X is 1 minus h is 5 squared plus k is 7. All right, so this is just straight substitution. So I'm going to do two things to start solving for that a value. I'm going to subtract 7. Okay, so let's see, negative 9 minus 7, negative 16, okay, equals a times, now we've got, let's see, 1 minus 5 is negative 4 squared. Please be careful, if you're not sure what negative 4 squared is, if you're going to use a calculator, please make sure you use parentheses. That turns into positive 16. Divide both sides by 16. So a is equal to negative 1. So again, we're going to now use the information from our vertex and this a value to generalize the function. All right, now I'm going to use f of x again. So f of x equal to negative 1 times x minus 5 is my h, squared plus 7 is my k. You could also just leave it as negative times the quantity. You don't actually have to put the 1 there. I'm going to leave it though. All right, so that's the first two examples. I'm going to go ahead and scroll on down to the next two. Okay, at any point if you need to pause the video, rewind, send me a message because you're confused. All right, you've got some options. All right, we have a vertex point of 0, 4, and it passes through the point of 1, 0. Okay, so again, clarifying just what we've got, 0, 4 is my vertex, so that's my HK, and 1, 0 is the other random point, that's my XY. All right, so y is equal to a times x minus h squared plus k. Y is going to get replaced with 0. A is the part we don't know. X is going to get replaced with 1 minus h of 0 squared plus 4. Remember, the y, x, h, and k are just these pieces of information off to the side. It's not magic, okay? So two things are going to happen. I'm going to subtract 4 from both sides. So negative 4 is equal to a times 1 minus 0 is 1 squared. So a is times by 1. It's just 1a, all right, or in fact just a. So we've now solved for a. We know what that is equal to. So I'm going to go ahead and again generalize that equation using my vertex and the a value we just figured out. Okay, so f of x is equal to a is negative 4, x minus h is 0 squared plus my k value is 4. Now I'm going to do one thing to clean this up. Because the h value is 0, x minus 0 is just x. So that's going to be x squared there plus 4. All right. So this doesn't really look like it's in vertex form, but it actually is because, again, you could put the plus 0 in here or minus 0, and it would put it back in that vertex form. All right, so that's problem number 3. We've got one more here. Let's see. We know we're going to get a vertex point. In this case, it's negative 2, 8, and it passes through the point of 1, 4. Okay, so negative 2, 8 is my HK. 1, 4 is my XY. Remember, that's any other point. It's any point on the parabola is representing the points XY. The vertex is just special, and it gets to be also called HK. All right, so vertex form, y equals a times x minus h. Whoa, I don't know what I was just trying to write there. Squared plus k. I don't know, some kind of weird parentheses plus a squared sign at the same time. Let's see, y is 4. A, of course, is the thing we don't know. X is 1 minus h is negative 2, so there's, be careful there, okay, squared, plus k is 8. All right, I'm going to subtract 8 from both sides. So negative 4 is equal to a times. So this is where you want to be careful with your signs. Yes, there was a minus sign from the original, x minus h, so there's minus, but h itself was negative 2, so make sure you're paying attention to those signs. 1 minus the negative 2 is 3 squared. So let's see, that's going to be negative 4 is equal to a times 3 squared is 9. Divide by 9 on both sides. That's not going to divide nicely. It's not going to simplify. So it's done. Like, I'm okay with that as the a value. Just leave it. Okay? But you are going to take this information and write me an equation here to represent the quadratic that passes through the point 1, 4 and has that particular vertex. So f of x is equal to negative 4/9 times x minus negative 2 squared plus 8. Again, I'm going to do cleanup because I'm not a huge fan of having that double negative inside the parentheses. Well, I'm not really a huge fan of having a double negative anywhere. Okay. So, all right. That, ladies and gentlemen, is how you write a quadratic equation when you know a vertex point and you know any other point that the parabola passes through. If you have any questions, send me a message. Otherwise, I hope this helps with understanding how to do these problems.